Alright, I think I should be live right now. Sort of making sure that everything's going okay. On my stream, it's still showing the person I'm hosting, so I'm gonna refresh and double check if that's working out. But yeah, I think hopefully I should have fixed the echo problem that I was having yesterday, or last week, I suppose, which I think was due to stereo versus mono. I'm not actually sure if that's true or not, but we'll see. Yep, everything seems to be working correctly. So hi, I'm Rippin' Pepperinos, and we're here again with another Shenzhen Day and Shenzhen IO. So yeah, I guess in the last week, sort of just starting to getting started with the game. We sort of got our first emails. Let's look at those. Yeah, so we looked at the emails, worked on a security camera, learned the importance of reading the manual, which will definitely be in play, as you can see here, I think, which is, I've got my hotkeys set up, so I'm really excited about those. Might forget to use them occasionally, but I'm hoping for the best. So yeah, we made a security camera, learned the importance of sleep. We have this person here who's pretty cool, talking about Shenzhen and sort of introducing and stuff like that. Got this solitaire game, which I've heard a lot about. One of my friends says that they've played nearly 60 wins of solitaire. So I guess, like, I don't know. In the office today, I was working on, let's see, what was I working on? I was working on getting a mechanical test fixture sort of set up. Not a lot of data sheet looking at, so I'm not really looking forward to jumping into that. So I guess I'll start with solitaire, let some more people get onto the stream. But yeah, geez, so, man, so this solitaire game, alright, I didn't really know where to start. There's like, you have these dragons which will take up space at the top, and then the rest is sort of just like solitaire. Yeah, let's get at this. Okay. So yeah, I don't really know what to make of this game. I don't know. I was definitely in this game for the datasheet parts, but apparently, like, some people like barely even play the game and they just play this instead. So I don't know. Each their own, I suppose. Let's see. All right. So yeah, let's do this. I think the important part is just really thinking a lot of moves ahead, which I don't know. It's not exactly that as easy when you're just sort of playing around with this, but like, I don't know, I feel like the datasheet part, right? Like, all of the answers are there. It's just a matter of like you actually looking out and trying to find where it is. Yeah, like, I'm not sure if that makes any sense, but oh, I see. So they're not prompting immediately for those. But yeah, like, I feel like when you're just looking at the data sheets, it's more of like a puzzle, whereas this is like, it's all random and just thinking ahead. I'm not digging this as much. Not sure why it's so popular, but maybe I'll get addicted to it. We'll see. So I think I can do this. All right, this is a better start. If I do this and I get that one out, cool. Wow, maybe just me just yammering about things is actually getting me somewhere. But yeah, I don't know. I don't know. Yeah, I'm working at the Toyota Research Institute for the summer, and school's about to start after Labor Day, so that's coming up pretty soon. Yeah, so I spent a lot of days doing mechanical testing, and it was pretty chill. Not really sure what else to say about that. But yeah, definitely, like, I'm the most experienced EE person on the team, so definitely using a lot of the skills that like come from Shenzhen IO in my daily job. And I think I already screwed up. Yeah, I think I screwed up. Rip. Yeah, can't. Unless... Oh no, I can do this for here. Okay, cool. Oh, that's nice of them to do. Although I do feel like one of the fun parts of like playing solitaire was like clicking it. I mean, definitely the fun part about Microsoft Solitaire is seeing the things bump down. But let's see. So if I can get, there's this fa here. Yeah, okay, now I think I'm screwed. Well, it's funny how those things work. Whatever. That's enough solitaire. Alright, back to the fun part of this, I guess, which is the engineering. Oh, it's sort of interesting that the levels are sort of caked in with the emails, but alright. Let's see, so rubbish audio thing, which was just implementing the equation that was in this this data sheet. Let me get that up. So yeah, there was in the application section. I'm just gonna skip ahead. No, not there. In the application section, there's some company that's selling their audio source, and they have some formula in there. No, we're still. Still just talking about products. There we go. I think this is just to say, like, please no, actually look at the data sheet. But here we go. That there's this sound company, and they've got this formula here, and it's like actually implementing it in hardware. So this would be like hardware equations. Yeah, like I can see this is reasonable. But at the Sunnyvale Institute for Audio Engineering, it's funny. Sunnyvale is like a city in Silicon Valley, where actually Apple has a lot of buildings out in Sunnyvale. Yeah, well, I mean, like, okay, I guess that's also something about, like, American companies sort of contracting out their work into there, out to, you know, what's it, China, and so, like, oh, you've got to just make some crappy thing, yeah. Work's work and all, even when you have to help a dodgy American company market rubbish like this as premium kit for audiophiles. So, yeah, let's go. Open in ConceptCAD. And go. Alright, so looking at the data sheet, again, we've got audio out has to equal audio in minus 50 times 4 plus 50. So there's audio in and then audio out. Cool. So the signal from audio in should be copied to audio out, applying the algorithm when the maximize switch is on. Okay, this seems pretty straightforward. So, we basically need to use this pin as like an if, and then just sort of move the same thing out. So I'm just going to be cheap and, well, I guess expensive technically, and use the fancier chip for this, right? Because I can do this, although, oh, it's still the same number of outputs. Okay. Let's see. So I guess I'm a little confused about these XO parts. Let me slap one of these and then go back to here. So audio out equals audio in. I'm just going to copy this and put a little note. Still don't really know what the bridge does here. Oh, I guess, so what is it? In minus 50 times 4 minus 50. Okay. Or plus 50. That's the equation I have to do. Yeah, so I'm going to go back to the datasheet and also look up what is needed for the X bus, because I'm a little bit confused about that. The only time that we've used it so far has been for a display image, but yeah. I do wish that I could have printed out this thing and actually had a written copy, especially for taking notes on, because that is really sort of how you do it. My first microcontroller class at MIT was a 8051 manual, and literally like a book like this thick, and then you're like, go. And the first lab, honestly, was just trying to find all of the magic numbers in there that you need to use. And an 8051 is like one of the chips that they used in the 1980s, so it's like really, really old school. Nowadays, your first microcontroller class would be probably an Arduino, which is the most common one, but the reason why the teacher said that he wanted to do an 8051 was because it doesn't matter what kind of hardware you use. The same principles of looking through the datasheet, trying to find what you need to use, and sort of writing whatever obscure language that you want to do things in. That's basically how microcontrollers work, and I definitely appreciate that. But not having a physical thing means that you can't I can't fill in my visa application to the People's Republic of China, which is not actually just thorough. When I got my visa application, because I was going there for manufacturing, it's pretty nice. You can get a 10-year visa now, but it wasn't this form-like. I don't know, I'm pretty sure that I was just here's my passport, and then they like scan some stuff and they're like, bam, here's your visa. Well, actually, more like, let's take your passport for a few days and then bam, here's your visa. But embedded systems engineer, that's cool. Oh, so this is in the future, 2026. Okay, I didn't realize that this game had a date, but yeah. Lohu. Oh man, God, this bringing back memories. God, I don't really know what else to say, but like just the different districts, and then they have a pretty good public transit system out in Shenzhen. So yeah. One of my regrets was I didn't really get to go explore Hong Kong while I was out there. My trip for Square, we were located in Dongguan, which is about like an hour away from Shenzhen, and then so there was like no time to hang out in Hong Kong. But for Shenzhen, when I was with Apple, some people went over the weekend, but it was a little bit more hectic. Like you had to organize your own transportation and everything, and I just really wasn't up for that. It's very exhausting working in the factory. So I did get to go to Dafan Oil Painting Village and have some fun there. If you guys are interested, please let me know, because I have some fun stories about the oil painting village. Anyways, here we are looking at the I/O values. I/O values are continuous signals from 0 to 100, not 0 to 1 like in an actual electronic system. Discrete data packets. XBus is commonly used to transmit data between two microcontrollers and complex input or output. Simple I/O bus can be written at any time. If a read or write is attempted without a corresponding operation, then the operation will block. So it seems like we don't really want to use XBus for this because we don't want to block it. Let me go back to the game and shut off the data sheet. Yeah, should be copied to... So we don't want it to block it. So unfortunately, I think this means we have to chain to... What is the MC... What is this? Oh, that's all XBuses. I see. Oh, so that's why they're not recommending it. Okay, we're still on tutorial levels. I'm okay with that. Okay. So let's see. Oh no, so I still have to have an output. Let's see. But I don't want to be blocking. That's the main problem. So this one has... So this one still only has 2 outputs. Okay. I probably could redo my last one not using this. Yeah. Let me just... Sorry for this. I'm gonna go back and check my last one, because I'm pretty sure I was pretty tired when I did this. Yeah, I could have redone this with just this. Probably not enough. Not this one. Oh, whoa. Oh, they're letting me use... Alright, I'm not sure why I would do that. But yeah, I probably could have just done it with this one. Alright, or the simpler one. Yeah, although there's the issue of amount of code. So for this one, it's you want to add and subtract it, but I guess the code becomes a problem, right? Because that's kind of a cute way of doing it, of like, oh, the bigger chip has more memory, and like allowing you to do more of commands and stuff. That's like a cute way of sort of simulating that behavior. But is there an easier way? Okay. So start 1. Basically just checking if adding and subtracting, if I'm getting any signal on those 2. Moving 0. Okay. If it's... So don't subtract. Okay, if the accumulator is less than 0, then don't subtract it. Okay. I wonder if I could just jump push. How many lines do I have? If I just... I remember I could get copy and pasting working last time. Okay, yeah, it really is a limited amount of memory. Okay, probably not worth dealing with this, but that's sort of interesting. Control Z. Oh wow, Control Z works quite a bit. Anyways, thanks for satisfying my curiosity a little bit. But back to, yeah, so my friend Uraza probably was able to just do it with that one. That makes more sense. Alright, back to this rubbish audio. So, let's see. So this is not actually going to help me unless I feel like I need more programming. The main thing is that I need to have this in here. I wonder what happens if I do just do this. So what I'm going to do is just like a simple test of seeing, so I'm going to say move P0 to P1. Pin type mismatch. Okay, so it's actually not letting me do that, just period. Okay, so I do need to use 2 microcontrollers. And let's see. So I have to, I'm only allowed to connect this one to here. So I guess this is where I'm using the datasheet of like X0, using X-bus pins to talk to one another. So I'm going to say, okay, oh boy, I forgot all the vocabulary for this. I think it's like test if greater than X0. I'm going to test if it's greater than 0, and then if it is, I'm going to apply the formula, otherwise I'm going to just move P0 to P1. Okay. Yeah. So I guess I should just, it should be moving the accumulator, because otherwise I'm going to move P0 into the accumulator. Or no, I should do that regardless. I should always be just moving P0 into the accumulator, because that's going to be moving whatever signal I get from audio in over to audio out. And then if I find that, so the main problem I'm worried about here is that I think this one is going to block. Oh, I can't. If I had enough space, I would put a comment there that explains it. Too many operands. Is it like a hashtag? Yeah, okay. Mixing up my programming conventions. Oh boy. Yeah, not sure if any of you guys computer program, but that's like definitely a common problem. Just, you know, do I put a semicolon here or do I not? Who knows? Okay, so if it is, then the magic formula is, so it's probably more efficient to say like 4 times in minus 150. Unless I can't subtract 150, we'll see. So, okay, so mul by 4, and then sub by 150, and then that should do it. And I'm going to say if P0 is greater than 0, if it is, that means there's a signal, and I should move to X1, and if not, I'm going to move 0 to X1. Alright, let's test this out. I'm not sure if this will work. Let's go. Alright, friggin' sleep commands all the time. I mean, I don't know what I feel about sleep commands. Alright, go. Oh, ooh. Cool. That worked out. Yeah, I don't know. I feel like putting in intentional sleep statements is like not something that I normally do, but like, it seems like a kind of, hack of freaking like, you know, like the actual processor takes time. I don't know. Like the loop itself. Oh, okay. So what usually happens in actual computer programs is that like the loop itself that I think is going around usually has its own delay in there. So you don't usually put any sleep commands. When I was taking my microcontroller class, I definitely didn't put any sleep commands that I recall. I'm not sure if that's actually true or not. I'm pretty sure that's true. Just because it would just go through signal. But I guess like this is trying to pretend that we're some low-level signal. Or I can imagine that some of the puzzles later are going to like, oh, you have this one sleeping and like sampling for a lower amount of time. I feel like it's a poor solution right now, but I trust Zachtronics game design, so Let's see. Return to email. Holy crap, this thing is awesome! It blew the speakers clear off. I don't know. I don't think that's what you're looking for in your speakers. Self-driving cars stuck in a loop. Cars said, oh boy, legal. If you bought a self-driving car and your car was involved in a rogue loop incident, you may be entitled to California. Continues to drive. Wow. Refueling itself when necessary and ignoring orders to stop. Wow. Okay. That's interesting. If we actually do get self-driving cars in 2026, I don't think we have to worry about sentience. I think it's interesting, though, that... Yeah. I don't know. I work at Toyota Research Institute for the summer, right? And, like, Toyota, you don't get any prizes for guessing that we're working on self-driving cars is one of the things that we're doing. But, hey, if we could make a self-driving car have sentience and, like, not want to let you off, then, like, I would already be really impressed. But what do I know? Shenzhen's got moderate drone activity. Infrared sensor. I am in the process of setting up closer tie-ups with top global firms, and I'm working to secure higher profile work for our company. Infrared sensor. Passive monitoring stations to detect illegal activities. If it's against the law and it generates heat, we'll detect it. Okay. Well, let's go back to making freaking light up esports signs before we start being part of the military-industrial complex. Oh boy. I mean, that's definitely one of the weird things about being, like, I don't know, working at MIT and sort of working in these industries in general, being part of the military-industrial complex, which I'm not sure if you guys have heard of, but that means, like, you know, military wants to get bigger, so they start making new technologies, and then from there, like, the industry creates stuff, gives it to the military, and it's just a cycle. Eisenhower's closing, address speech, I'm forgetting the term for it, but basically the last speech that Dwight D. Eisenhower gave when he left office was really condemning the military industrialization complex. And that was in, like, frickin' 1950, right after World War II. So, I don't know, you can look at, like, MIT's close connection with Lincoln Labs. There's probably other examples. Georgia Tech and Georgia Tech Research Institute. I'm just saying what I know, but I'm not condemning these institutions in particular. But the DARPA Robotics Challenge, all of these things are military-industrial complex. And I don't know, it's interesting. I personally don't think I could work for a direct contractor like Raytheon or something like that. But things like, Lockheed Martin, they make planes. I think I would be okay working for them. But, aren't they bombing civilians and things like that? Oh, and then you see, like, these big corporations also sponsoring math competitions for middle schoolers. There's one called Math Counts, which I did, and I remember sitting in the room, like, seeing all the Raytheon and Northrop Grumman sponsorships, and I was like, wow, they want me, like a middle schooler, to make bombs to drop on other people. I just thought that was the weirdest thing, but what are you gonna do? That's part of the world we live in. Anyways, so all of this is just to say, like, hey, I'm not gonna work on that right now. I'm gonna make slide up signs for esports people. So, let me just make sure that everything's still good on my side. Alright, click 0 and click 1 are simple outputs. Okay, so these are the outputs. Connected to display segments. Oh, okay, so these are outputs. Fixed repeating signals as indicated in the verification tab. So I want click 0 and click 1 to be... Okay. So, okay, so here's where your different sleep schedules come in. Not that bad. Do I have, like, an inverter? Wow. Not recommended. But here's my freaking inverter! I'm pretty sure. Oh, I can rotate it. That's cool. I can't wait to get, like, geometry starting to come in here. Because, like, that's gonna be the closest, like, simulation to freaking, like, wiring up circuits. I'm very excited for that. I get to this programming stuff. Anyways, I assume this is an inverter. What is this? A freaking LC... What part is this? Come on, you need to give me a label. LC7OG04. Alright, let's look at that in the datasheet. Yeah. Freaking search is your best friend, except when you spell things wrong. LC70. Alright. Yeah, one input, one output inverter. Yeah, so why don't I just slap one of these babies on? And, you know, do this wazoo. So I'm just gonna move 100, P0, sleep 1, and move 0, P1, P0, sleep 1. Okay, so that's done. Drinking. Okay. Okay. So this is 1, 2, 3, 4, 5, 6. 6 and then 1, 2, 3, 4. Okay. So there's a sleep 6 and then like a sleep 4. Okay. Okay. I wonder if I can bake this in to here, like also moving in P1 and then I don't know. Seems like a little bit of an overkill to do it that way. So I think I'll do the same inverter trick. I'm not sure. Part not recommended. Screw you. I think it's a little unfortunate you can't have it vertical though. I don't really know why they're giving that limitation out of all the limitations. But what do I know? Drink 2 and drink 1. Alright. So I'm gonna move 100 to P0 and move 0 to P1. Oh, does it work like that? Yeah, it should work like that. Okay. Sleep 6. So I'm going to move 0 to P0, move 1 to P1. Oh, I can't do it as simple as that, because they all want to sleep for 6. Yeah, that's not a complete inverse, so I don't think this is actually gonna help. Whoop, 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 whoop. Well, let me make sure that the first part works. These out. Okay, let me make sure that my sleep idea works. Okay, yeah. So that definitely does. Oh, that's interesting that it's gonna default to 0. Okay. So I don't really want to do... Alright, click 0 and click 1. They're like a timing beat. Can I use that in any way? Not unless I'm counting, which doesn't seem like it's as good. Okay. Let me see. So I want... Okay. I mean, if it was just this, like... Yeah, this solves for drink 0 and drink 1. Also, I have a lot of space, so I could just be lazy and like slap another microcontroller down, which I think I'll think a little bit more, and if I can't, then that's gonna be it. But, let's see. Okay, so I can just move 0 to P1. Oh, I can't connect the port to itself. Okay, that's good to know, I guess. So that would work for the first bit, but then it's that bit at the end. Okay. So I think what I want to do is that instead of sleeping for 4 here, I'm going to say like move 1 to P1. Oh, I could slap like an OR gate or something like that. And then so when it's 1, it would prioritize it. I still think it's a little overkill. Alright, whatever. Moving 1 to P1. because like the main problem is that like these are the same until it gets to this part. So let me think. All right, moving 1 to P1, and then I want to sleep 1, move 1 to P0 to P1, 2, move 1 to P1, and sleep 1. Right, which I don't have enough room for. Okay. Okay. Let's see. So no. So then I have all these logic gates basically. So I got my. Huh. This is weird. Okay. So just showing off some chips. They've got one side is an AND and the other side is a NAND, which is like there are chips that both give like the result and its inverse out. Oh, sorry. I still have my data sheet up. So they still have like their AND and NAND. Like this is a pretty common thing to do, but it's sort of surprising that they like denote it this way. So the little circle means that it's going to be the invert output. I guess like I'm not really sure. So that's a NAND, and this was an inverse, and then this one is a OR, or NOR. I don't really know a good way to say of like how to know it, except like I always think of like NAND, like AND has a D, and so this one's shaped like a D, and then OR, O is a round word, so this one's shaped like an O. But yeah. Oh, here's an XOR. See, it's got like a fancy thing. At least I'm pretty sure that's an XOR. Oh, that's all the logic stuff. So all I have is logic chips, whatever this crap is. Yeah, I should go look at the data sheet, but you know, it's more fun to just fiddle around. Especially you're not at risk of freaking electrocuting yourself or like causing magic smoke to burn out. That's always so. You know, when stuff is available to be played with, you should just play with it. Today for work, I was working on something that was like required me to like lug a freaking power supply everywhere. One of those big beefy boxes that hours can go up to 30 volts. It's like pretty hefty. But I just wanted it to power just like, you know, freaking Arduino project. And but you know, when you have a power supply that can go up to 40 volts and you know all you want is 5 volts, let me tell you, you really double check the crap that you set those settings correctly. Because otherwise, yeah, in terms of burning stuff out, it's definitely the case. Yeah, so I don't know. I'm pretty digging this game about how they're doing it, but let's see. You know, at this point, I might just like chicken out and just YOLO it. So, yeah, whatever. Sorry to be lame. Like, I feel like it is a sort of like a weak thing of just like slapping on more microcontrollers, but you know what? If I have more time afterwards, I will go and optimize it. Thank you, BioFavor, or Pouvoir, I don't know. But, you know what? Like, it is sort of, someone last week commented about, like, you're playing a game that's the freaking, like, it's the, whatchamacallit, just, like, it's your job, right? You're just playing a game for your job. And, like, I question a lot why I'm playing this game, but here we are. And get rid of that. Yeah. Forgive me, Father, I have sinned. I am using freaking, whatchamacallit, multiple microcontrollers when I probably could just solve the game with one, but whatever. Alright, so drink 1 and drink 2, I'm going to move 0 to P0, move 0 to P1, sleep for, what is that, 6, I'm going to move 1 to P1, P0, sleep for 2, oh, sleep for 1, move 0 to P0, move 1 to P1, sleep for 2, move 1 to P1, sleep for 1. Rip. Okay, maybe this is where this is actually mildly tricky. Grumble, grumble, grumble. could outsource it to here for one of them. Move 0 to P1. God, this is not efficient at all. Oh god, no. That's bad wiring. Okay. Let's move this up here. Yeah, there we go. There we go. Give me some more real estate. So PCB routing, for those of you who don't know, PCB routing is actually a pretty tricky part of wiring stuff up in the real world, because if you're not careful, you're just going to... Okay, so like this is something that computer programmers often don't realize, is that like it's not just like, oh, the signals are going to magically get there. You actually have to think about how it flows. So stuff like capacitance, if you move your wire, if you have two high voltage wires or high frequency signal wires together, they can actually kind of go against each other. Sorry, that's not a very good description. You have two high voltage, high frequency wires, and they're running very close to each other. And since they're like changing very fast, the signal on one wire is actually going to affect the signal on the other wire. And so like you'll get this capacitive coupling, right? Because a capacitor is basically two sheets of metal with some space in between it. And then you can have some charge on it. So you have to be careful in your wiring, for example, that like you don't have two high frequency wires right next to each other, because otherwise the signal is going to capacitively couple, is the term for that. So, you know, a lot of computer programmers don't think about this, because like, oh, it's a freaking wire, all the wires should be going together, right? No, that's not how it works. I'm not actually saving any space by doing this wiring, I think. It's also good that they're not charging me for wiring, because like the amount of copper that you put down on a board also could affect things, but it's not in this game. Alrighty. So I think I'm going to have the drink 2, which has the least amount of crap in there. So, well, no, because then move 0 to P0, move 1 to P1, sleep for 2, move 1 to... Oh, sleep for... Oh, it's really that one that's the annoying one. Let's see. Not everything can be super easy, unfortunately. I just want to get over this and start going back to the military complex at this point. Moving 0 to P0, sleep for 1, moving 1 to P1, sleep for 2, move 0 to P1, move 0 to P1, and then sleep for 1. Okay, I think that fixes that. I will bring that to drink 2 now. Alright, so moving this to drink 2. And then can I do something fancy? What's that? I think I could, actually, but I'm just going to cheat on this. So move for 0 to P0. Sleep for 6, move 1 to P0, sleep for 1. Yeah, this is pretty shoddy programming, and I do deeply apologize for people who are min-maxers, but... Alright, let's go. What? Sleep for 6, move 1 to P1, sleep for 1. Oh, friggin' the hundreds. Alright. I just want them to give me, like, a good old-fashioned, like, 0 to 1. Back in my day, things were binary. None of this, like, 0 to 100 crap. Let's go. Yeah. Oh, cooking and drinking. Yeah, that's my kind of life. I really should know what the first character is, but I'm just gonna pretend that it's, like, Jayo. The second letter is, character is definitely Yo, like, foil. Ha! Did it in less cost than, Uraza did, at least. And less power usage, and less code. Dude, using 3 microcontrollers still did it better. Oh, it is Jayo. Okay, cool. That's awesome. My Chinese skills are not total crap. Jayo is like, you know, like, step on it, like, add gas, literally. And it's like, go do better, you win. Alright, blah blah, emails. Looks simple, just a few states. Well, I used 3 microcontrollers, and I felt bad about it, so thanks, boss man. It looks like the Solid Steel gamer is really clicking the mouse button and drinking her soda. It's going to be huge. Yeah, female, freaking, not this one. Female esports players. Get some representation in there. Nice. Oh, man. I don't know. I feel like I should keep automod on, though, but, like, whatever. I don't know. Oh, I guess for the people who are only watching me because this is for Jeopardy, I recently got the phone call, and Tournament of Champions is going to be airing November 7th to 17th. November 6th to 17th, whatever. Like, second or third week of November. I'm going to be filming in September 15th, I think. Yeah, so tune in and watch me get my butt whooped, basically. We'll see how it goes. I don't know how many people are here just because I got on Jeopardy. I mean, I was definitely planning to keep doing this stream because it's sort of fun. But because of this game in particular, just me ranting about manufacturing because I'm a nerd. What was it? Yeah, I mean, like, I ended up finally getting my ass off the couch and finally streaming this because of, like, I got internet famous again, so thank you r/boottoobig and frickin' internet. Whatever. Here we are. Alright, so we could keep punting on military industrial complex, working remotely. I will be working remotely today and maybe tomorrow. I've been stuck in a traffic jam on the way back from an airport since then. I have food and water in here. Yikes. I would not be surprised if there was traffic that bad in 2026. I don't remember traffic. I remember just, like, crazy freaking driving in Shenzhen, where people, like, going all over the place. You know, the usual, like, I am in a developing country and nobody follows traffic laws. Program a Jeopardy buzzer in the game. Isn't that kind of easy, right? Like, is there a sandbox mode in here? Come on. Prototyping new ideas, is this? I've set up an empty prototype board for us to experiment on. We can test with some different parts, too. Custom LCDs? Carl, come see me. Design and create an electronic game. Wait, no, I want my sandbox. Where's my sandbox, Actronics? Oh, boy. Okay, so I can make my own game. Virtual reality buzzer. What is this? Xiaomei? Oh, small pretty. That's literally what that means. She's set to move in with me next month. It's easy for someone to sneak up behind me. Oh, okay, this is a lot less sketchy than I thought. I thought this was like some, like, sex toy that we were making for this dude. A simple vibrating buzzer that attaches to a VR headset, so it can be felt even during the most intense sequences. See, I just, like, auto-corrected vibrating buzzer and, like, intense sequences, and then was, like, Kappa, so connecting that to a radio controller, Xiaomei could advance me when she needs me with no chance of me getting caught by surprise. Congrats, David. Thanks, product manager. Note about the radio chip you'll be using. Normally reading XBus causes the microcontroller to block until data becomes available. However, this radio has it. That's pretty nice. Non-blocking XBus buffer. Yeah, so I was right about the blocking part at least. Yeah. I forgot what David's deal is. Also, I just want to say that, like, I just realized that the fact of having your email system be, like, your task list is, like, actually just the same use case of using your email as a to-do list, right? Like, it's literally the to-do list. It's literally, like, the tasks you have to get done in this game is in the form of email. But anyways, what is David's deal? Let's go to welcome. Alright, so this is Big Boss Man, leader at, I guess that's to the point. Big Boss Man, a kid who is from the UK and is also kind of in the same boat as you. Joe, the PM. Lily, the very serious. Oh, she's VP of product? What? Alright, so Carl's fellow engineer. Joe Hightow is a product manager. Lily is I guess I'm Lily, right? So Lily is VP of product. international product manager. Oh, he's the dude who's like really into like Chinese culture, I guess. Okay. Alright, and that's small boss man, but big boss man to us. Okay. Yeah, no, man. Big boss is Wu Forever Red. Really? Wang Yonghong. Okay. Well, rip. Like, we're already part of the military-industrial complex, right? Like, I'm ignoring this, like, important message of freaking, like, heat-seeking. If it generates heat, we'll detect it. Let's open this up. What's this thing? Should be armed and disarmed. Sensor reads at or above 12. Oh, it's just a freaking alarm thing. You know, what could possibly be wrong with this? Like, we're clearly part of the military-industrial complex. Man. I didn't see that many cute mascots when I was in China for stuff. Like, I definitely think the whole part of, like, in Foxconn, you're living in a factory, and, like, there's a frickin' Foxconn town, I think is what they called, where, like, there's a supermarket, and you buy all your needs there, you live on a dorm on the Foxconn campus. I already think that's a little weird. I never went to Foxconn town. I was too stressed out in the main part of the factory. But a lot of my coworkers had gone there and said that they bought, like, you know, like a charger or something. There was apparently, like, a big volleyball match or some kind of sports match between the American engineers and the Chinese engineers. Oh, it was badminton. Yeah, Chinese people like badminton. So we got our butts whooped. Anyways, where's my sandbox mode? I'm gonna make a freaking Jeopardy buzzer. Control panel. No? Okay. Puzzle archive? Okay, I don't know what these buttons do. Auto format code. Yeah, that's a nice feature. Okay. Well, whatever. I will make, well, I'll make a virtual reality not sexual buzzer, I guess. Oh boy, what is... Radio RX. Wow, look at this. They even got the freaking antenna on here. Yo, like your freaking like chip antenna. Looks like an esophagus the way they drew it, because you really need these like two ends to eventually go into the circuit. But yeah, no, dude, they have an antenna. I'm excited about that. And that's like actually sort of separate from the electronics, because like really an antenna is just like this random piece of wire, and it like picks up signals, and then you like do different things to make like the shape or pick up signals or whatever. Okay, non-blocking X bus connected to a radio receiver. Buzzer is an output connected to an electromechanical buzzer. When we read a data packet, read it and execute. Oh, just turn off and turn on. Okay, slap one of these cheap things on here. So, shouldn't we just need to connect the TRX? Like, we're not transmitting anything. Yeah. Okay. It's work. Alright, so this should literally just be like, if x0, if it's greater than 0, moves. Isn't this just it? Otherwise, move 0 to P1? Is that really it? It seems really dumb. Oh, if it's... Yeah, that should work. Oh, right, and the friggin' sleep command, because dumb programming language. Go! What? No. So... What? Why should it be on and minus 999? Oh, because it's a buzzer. Oh. What? So when it's 0? Oh, okay, so it's keep oscillating until you receive a 0. Gotcha. Okay. 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 So keep oscillating until you receive a 0, basically. So if it's greater than 0, we don't necessarily want to do this. So I'm gonna say like oscill is move. Wait, okay. It's depending on what time it is. Oh, okay, I got you. Move ACC to P1. Alright, so if it's greater than 0, which I think is also includes equals 0. So move 100 to... Okay, so then I want to not ACC. Or not, whatever... What was that called? The one that, like, flips it. Okay, language reference, here we are. Oh, that is the second register. Oh, that's the other useful thing about the bigger microcontroller. Right. Not. Oh, I just do not? Okay. Alright. Not. Okay, that's kind of dumb. And if it's equal to... If x0 is equal to 0... I'm not sure. Yeah, because the sleep is going to recycle it. So if x0 is equal to 0, then we move 0 to ACC. Plus that. Alright, let's try that. Ah, no. Okay, I don't think it's happy about this. Save. Alright, let's just go. Oh, huh. So it's not happy about this. So 9999, it's gonna sleep 1. So 1 goes in, so it's gonna 100 it. And then... Yeah, so... Oh, okay. So the reason it's not working is because from the x0, so then it's only going to oscillate. Okay, I got it. Okay, so if it is, I'm going to jump to OSC. And then this is push. So OSC is going to just be not, and then jump to push. So it's only going to oscillate. No, that's still not right. If it's greater than 0... No, I want it to keep oscillating until it's not equal to 0. Okay. Trickier than I thought. So, okay. As soon as I receive a 1, so probably if this is equal to 1, jump to oscillating? No, it's when it's when it's not equal. It's when it's... I want to jump to push. No, I want to move 0 to ACC and then jump to push. And then on the default case, I want to... Or I think when it's greater than 0. Otherwise, I want to not. Yeah. Right, because when it's greater than 0, I don't want to do anything. No, when it's when it's equal to 0. And then if it's less than 0, I want to jump to push. Alright, when did that do that? So, okay, so it's not equal to 1, and it's not less than 1. What? How is 1 less than 0? What? Does TLT mean something other than what I thought? TLT. Tests if the value of the first operand is less than the second operand. A is less than B, then it will go. Oh, okay. So I guess we can't do stacked. I guess we can't do. Okay. So I guess we can't do stacked like this. So if it's not equal to 0, I really want a greater than, right? So if it's greater than 0, I want to not. No, that's back to the same problem I was having before. So, alright. If it's less than 0, it's less than 1. If x0 is less than 1, then I want to do something. Otherwise, I want to not. But I really want to check if it's negative 999. What if instead I had the accumulator be a bit to say whether or not to oscillate? So if x0 is equal to, oh, you know what? I'm gonna cheat. Woo! Let's use the big baby. All right, shoot. Give me that dat. All right. I think I need to deal with the wires. Nah, I'm okay. All right, let's cheat. Okay. So I'm going to have ACC. So I'm going to have dat be the indicator variable. So I'm going to say if x0 is greater than 1, I'm going to move 1 plus move 1 to dat. Oh, does it still work? Because I don't know if I can do this nested thing. Otherwise, okay. Otherwise, move 0 to that. Wait, no. Back to the data sheets. What's up with dat? It can be used in most contexts where dat is permitted. It is an error to use a register in a microcontroller if that register is not present on that microcontroller. Seems like a dumb, useless statement, but whatever. When an instruction is disabled by a test instruction, it will be skipped. Instructions with no prefix are never disabled. All conditional instructions start in a disabled state. Alright, touch activated light controller. To be used in a power constrained environments, blah blah blah, blah blah. Labels, registers. Yes, okay. Requires a fixed number of operands. Okay, this is just programming 101. Oh yeah, I wonder when these digits things are gonna come into play. Like, I don't really see any reason why you would care about digit-specific things. I think it's the attempt to make like a bit shifting, bit-specific thing. In a lot of programming languages, you can like bit shift, which means you like shift the bits back and forth, but I don't really see why that's useful right now. T equals T greater than T compare. Oh, yeah! Yeah, that seems useful. Okay. Alright. TCP 0. There we go. Let's get rid of this and go back to being poor on microcontrollers. So, okay. TCP x0, 0. Okay. So we're comparing 0 to that. So if it's greater than that, which means it's gotta be 1. If it's not, then it's gotta be negative 999. And then if it's not, then it's just gonna be not. Okay. Cool. What do I do with this? Okay, so if it's 1, I want to start oscillating. Okay. So eventually I'm gonna have to have a move accumulator to P1. If it's minus, I just like stop. I just don't do anything. I'll just delete that when it comes time. And then if it's 0, I want to jump straight to, I want to move 0 into ACC, and I want to jump straight to push. And push is going to be this stuff. Okay. Okay, so minus should actually be I really need to have another data line, I think. Yeah, I actually do think I need to have this one. I'm gonna copy all of this into here. Because I need to have that second comparison. TCP helps me out a lot, but I need to still be able to say turning it on and off. Yeah, so I'm gonna move 1 to that. I'm gonna jump to push. I'll jump to push. Minus, I just want to jump to push. Regardless. And then for no, I want to move 0 to that. Yeah, I think I want to... Yeah. So then if I jump to push, I'm going to move ACC to P1. Well, let's see if this works. I'm not sure if this going to work. So I'm going to test if that is 1. If that is 1, then I'm going to not. Okay. Not push. So let's keep this one still called push, and then for this one, let's call it I don't know, marker. Mark. Hi, Mark. Well, hi, Mark. So the Disaster Artist is coming out soon. I'm pretty excited about that. I really do like the room, pretty unironically. Yeah. I don't really know what else to say about that. Other than, like, I don't know. The advertisement was like all those famous comics was pretty good. So, I don't know. I don't know if I'll go see it. I haven't really seen the movie in theaters other than like Star Wars Rogue One. Yeah, that's the name of it. I liked it. I'm a Star Wars nerd. But, yeah. Alright, let's go. Sleep. You drive me to drink. Frick. Alright, what happened there? Doopadoo, life was good, and then we hit here. Okay. So compare if it's 0. It is 0. Let's move 0 to dat. Cool. Jump to push. Oh. Okay. Move 0 to dat and move 0 to ACC. There we go. Woo! We did it! Alright, so we can do this nested thing, although we do have to be careful about it, is what I'm seeing. But it is really useful to know that you can do nested stuff. Alright. Sweet. I beat Uraza. It's the important part. Beating your friends in meaningless code editing. Is that shishia? Alright, David. Thanks for being into the culture. Ooh. Things visitors say. Shenzhen days. I like my cultural knowledge. Goofy things visitors here tend to say. Every kind of Western visitor... Okay, come on. I thought China was communist, so why is everyone shopping at the store? Because one, the dude always thinks he's making some good observation, and two, it's complicated, okay? Communist China still comes right out of the 70s, and they're so surprised that they come here. You haven't been sitting around doing nothing since Nixon, neither have we. We built more than just the factories. I wonder what this must be like for... So, okay, here's another, more Shenzhen stories. It was really interesting going on these manufacturing trips because it was the first time I had been in China, like, not with my family. And because I'm a second-generation American, I look Chinese, right? Like, the only difference is that I grew up in the States, and I didn't grow up in China, but, like, genetically, like, I look like I'm full-blood Chinese. So, I didn't get any, like, weird stares or anything when I went through, but when I went with my American colleagues, especially, like, the Indian guy, like, ton of stares, you know? And, like, people were just, like, it's not an impolite thing in China, it's more just, like, you know, it's not like in America where you really don't want to get caught staring, it's just sort of, like, a thing that you do and it's okay. And I had never experienced that before. Because, like, actually, when in Apple, when I was a little bit more, not scared, but, like, more familiar, like, I would just, like, I was wandering the streets at night, trying to find some place to dance, to go clubbing, to be more precise. But, yeah, nobody gave me a second look. It was only, like, when I tried starting, like, reading stuff or, like, doing other things, when they were like, this kid is illiterate and, like, speaks Chinese really weird and only has a first grade understanding of vocabulary, and that's when they would start looking at me weird. But it was still an interesting experience. Yeah, no, so I do wonder what it must be like, sort of playing this game. This is also sort of still, like, exoticizing the idea of Shenzhen, right? Like, oh, Shenzhen is this place, like, let's go back to this freaking home screen, right? Like, it's this mystical place where, like, okay, this Pagoda nonsense is, like, actual nonsense. But, like, you know, like, what's out there? There's, like Huachang Bay and all of these things. Like, I don't know. It's, like, still exoticizing in a way, but at least it's, like, more realistic in terms of, like, yeah, this is an engineering job. This is, like, look at the goddamn data sheets. Oh, I'm still, speaking of which, I still have it up. Still getting used to these hotkeys things. So, it's actually sort of funny because I had a really hard time finding places to go clubbing in Shenzhen. Like, if you like bottle service, like, they would basically just fill up their entire bar with tables, you know? Like, there was zero dance floor to speak of. I've heard that the clubbing scene is a lot better in Hong Kong, but I never got a chance to go to Hong Kong. I was pretty much just in Shenzhen this entire time. So it was just, like, all of these, like, cool Asians, for lack of a better word, like, people who were just, like, really wanting to go there and chill and look cool, just sitting at these tables, and nobody was dancing. Like, the only people who were dancing were, like, the paid dancer people. So at one point, I just got really frustrated. Like, I even went to the expat area of Shenzhen. They call it Coco Park. So, I guess this is another thing interesting about the shopping part, is that, like, Shenzhen, like, Chinese nightlife, at least for, like, like, Guangdong area, is really centered around these malls. So, like, we lived, the Apple people lived near, Mixi Mall. It was also interesting because for Square, Mixi Mall was the highlight of the place to go to, in our trip. Because there's a very famous, Michelin-starred restaurant called Din Tai Fung, which sells really good soup dumplings. They have a franchise, and they have an outpost out in this Mixi Mall. So that was, like, our, like, end of the Chinese trip. We go out to Mixi Mall and have Din Tai Fung. But here for Apple, we just, like, live at this mall, and, like, we just go there and eat. It was, like, no big deal. Definitely showing, like, a tier of company in terms of, what you can afford. But anyways, so the expat area is called Coco Park, also centered around a mall. And then there's another one called SeaWorld. Yeah, like SeaWorld, like the amusement park area, right? But it's actually this boat that they've grounded into concrete. Like, they drove the boat up into this concrete area, and then there's all of these, like, random shopping areas and stuff like that. I never went to SeaWorld, but some of my friends did. Anyways, keep getting distracted from the story. I went to Coco Park, because I knew this was an expat area, and I'm thinking like, oh, if it's like an expat area, maybe they have like traditional American clubs, you know, that I can go and dance at, instead of like this nonsense table thing. And I went there, and like, sure enough, it was still freaking like a bunch of tables everywhere. Even though I went to like this German themed bar, it was really sketchy because all of the bouncers and all of the staff were wearing like Doc Martens and like military gear, and I'm like, dude, I'm gonna get beat up in this, and this is like way too military. But at this point, I had been going around Shenzhen for like several nights in a row trying to go to find things and dance. So I was like, you know what? Screw it. I'm going to go dance right here. And because it was decent music too, so I started dancing like on a table in the middle of this like German themed bar in Shenzhen, China. And it was fun. I danced well, supposedly, so like I got a bunch of stares. It was also probably because I was like the only person dancing in this mostly empty bar. But it was fun. Definitely going to check out Hong Kong if I ever get the chance to go to China for manufacturing again, or just China without like parental units, right? But I hear LKF is LK. I don't remember what it stands for. Something Kaifeng is what I would guess, but that's totally just pulling something out of my butt. Yeah, I hear LKF is like a wild time. But Hong Kong is also a really weird city because since it's been under British influence for so long, it looks and feels like a Chinese city, like very crowded, you know, very, I don't know, if you've seen Blade Runner, like how sort of crowded and everything gets in there. It's very similar to that. So it feels like a Chinese city, but there's all of these white people running around everywhere. And it's like a very weird feeling. My boss at Square said that he had a lot of experience, like a lot of friends over in the Hong Kong area. And I remember thinking like, oh, that's kind of cool, like a lot of Chinese friends. But like, no, it's like very clearly like expats and all of that. When I stayed at Hong Kong for my last night at Square's Chinese trip, we ended up eating at some Irish bar, you know, like, yeah, Irish bar in middle of China. Who'd have thunk it? But anyways, that's enough Shenzhen stories for now. I totally forgot how we got on the subject of clubbing and stuff like that. I'll go back to checking my email, just like real life. It seriously is Job Simulator. Oh, right. Yeah, it's China being communist. Dude, if you see freaking malls in Shenzhen, it's freaking crazy, man. Like, you think you've seen a big mall, like, it's also weird because people will be in these malls on, like, a Tuesday night, you know? It's not like in America, you're going to go shop, like, you know, window shop and see them. Like, these places are packed on a Tuesday night and, like, basically every night. And I'm like, I don't really know what people are doing out here. It's so weird. I don't understand the mall culture in Shenzhen. But alright, that's a lot of talking. I mean, I guess this is right, again, like why I'm playing the game is because I have a lot of feelings about Shenzhen. Or not Shenzhen. I'm probably like sounding like a noob if any like actual Apple or like actual like hardcore electronics manufacturing person is listening to this. Like I already sort of apologize. Because like, what do I know? I spent 2 summers. I spent a couple of weeks in Shenzhen, but like, I don't know. I have feelings. I'm sorry. I love reading like Bunny Huang's write-ups about things. So yes, please inform me if I'm wrong. I would love to be corrected because otherwise I'm just talking out of my ass. All right, wireless game controller. Wrapping up a project to make a game console and could use some assistance. The console is a tiny, super cheap box we're making for big Japanese capsule hotel game. Some free draws. I ping you, you tell me what's going on, nothing much more than that. Okay. Capsule hotels are cool. My friend stayed at one when he was visiting Japan. I don't know, I remember reading about it when I was a little kid, and I still really want to find out more about it, or at least try it out. So, alright, I'm gonna work on the freaking military-industrial complex, just because, well, should I? So I've got some LCD panels are fun. Click and hold this button to indicate that you have completed the objective. That's new. Oh, here is my prototyping area. Oh, I should have, alright. We could make a Jeopardy buzzer. Oh, sweet. Wait, open design. Wow. Oh, so just... What are these things? What? Whoa, what are... Whoa, I have so many toys! Whoa! Wait! Oh! It's... Yo, what... Oh, sweet, LCD... Oh, LCD screens. Whoa! 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 Oh, I got like a radio too? Yo, bruh! Bruh! Yo, freaking... Wow, I really could make myself a Jeopardy buzzer now. Oh man, dude, toys! Yo! What are these things? What do we simulate? What? Yo! Okay. Let's look at the data sheet. Freaking N4PB, is this like a buzzer? Okay, let's see this. Search. Push button controller. Parts plus your sorts for parts plus free shipping asterisk. Where's the asterisk? This part is for prototyping only. Carl. Thanks, Carl. Heh. Electromagnetic pulse weapons. I do appreciate this black box. You know, usually they don't even show you that it's a black box. They'll just say like, frickin' like, they just won't give you any details. You know, like try to find more details. Like, we were using a TI chip for Apple, and the data sheet online was just like 20 pages, whereas the data sheet that we had in-house was like 200 pages. And that was because like we were actually using the chips. They wanted to give us all the information. Nobody's gonna tell you like, oh, it's a freaking black box. Oh yeah, it's the freaking I Ching. I think I've already talked about this, but the fact that they actually intentionally chose a font that is, this is the font where you're typing in English in a Chinese word processor just really tickles me. Pink. Whoa. Okay, so we have our logic gates. Incremental clock. Oh, that's useful. Why aren't you a freaking quartz crystal? Why aren't you a quartz crystal? Do some actual freaking voltage stuff, and I don't know. Like if you actually needed like some timekeeping thing, like it would actually just be freaking quartz crystal. Although this seems like some minutes bong bong. You can't manufacture in America anymore. It's too expensive, and has all that expertise left the country anyhow. Made in America. Around a fab. I don't actually know if there's any fab. Well, I lied. No, I don't think there's any fabs in like silicon fabs in America that is on the same scale as like China, right? Like the most common one is TMSC, which is like Taiwan. No, TSMC, Taiwan Semiconductor Manufacturing Company, and Intel probably has a fab in the United States. Just for whatchamacallit, testing stuff out. But I think they have plants in like Malaysia and China. I really doubt that they have fabs out here. And I would be very skeptical if they had a freaking fab in Colorado. But small batch, sure, maybe. Wireless solution. Oh, okay, so that's our low power built-in antenna. So this would be a copper antenna. This would be that you actually put the traces in such a way that it can pick up signal. PCB antenna, I think is the term for it. All data received and passed through an internal non-blocking buffer. Yeah, that's like the fact that it's a non-blocking buffer is like pretty swag. True turnkey. Don't be a protozoan. Just get yourself a C2S ARF-F901. That doesn't rhyme. Protozoan. Protozoan. One. I don't know. I'm annoyed by that. Sound blaster. This looks fun. This looks fun. I want to play with this. Note and instrument. How does this work? Can I just move like a... I'm gonna play in the sandbox a little bit. It's more fun than freaking... What are people doing? Freaking Solitaire? Nah, man. I'm here to play Shenzhen IO and engineer some stuff. Alright. So let's set up a microcontroller on this and just like see what we get. Alright. Oh, these are X buses. Huh. What happens if I just move 100 to X0? Oh my god. I don't know what I expected. Alright, cool. What happens if I... Oh my god. Just... move 0 to X0. Oh my god, I'm so excited. Alright, so let's write some for loops. Oh man. Add 1. And then move accumulator to X0, sleep 1. I'm so entertained right now. I'm so entertained. Oh man. Alright. What if I also move accumulator to X1? How's this sound? Oh. Why is this working? Can I only... Alright. Move 1 to X1. Oh. Alright, loop here, move 1 to X1. Alright. Probably just not happy about constantly being set data. Alright, let's hear all these instruments. I'm really excited about this. I don't know about you guys, but like, the fact that I can make noise, it's just like, we learned QBasic in middle school, and then like figuring out how to make all the beeps and boops and like just really annoyed the crap out of everybody. So, I wonder why it's non-linear behavior. Turn on. Oh, maybe I should have actually read the datasheet. You know. Equal temperament. You got your well-tempered clavier. Not cavalier, as I thought for a while. New note or instrument change. Oh, okay, so that's why the loop was not super happy. Okay, so if we're starting at 36, then I'll do that. Includes bass drum and snare hi-hat. That's nice. Alright, so I'm gonna move 36 to X accumulator. Oh. Okay. Start. So this is start. And this is, so I'm going to say if, what is it? Oh, do I have more lines in program? Yeah, I have one more stuff. Alright, so if it's equal to, if the accumulator is equal to 97, check if it's equal. If it is, check if it's less than. If it is, keep looping. If not, jump to start. What is this? Oh, speed of loop? I don't know. Alright, let's see the other instruments. This is what I want. Just endless looping. Just going down the piano. Alright. Oh, I'm so entertained right now. What's the bass and snare? High snare, bass drum. Glass pad. Okay, I'm gonna check out this. Alright, these strings need a little bit of work. And let's see what the hi-hat. That warping at the end is really weird. Alright, and finally, bass beat. It's probably not. Let's sleep 2. So, yeah, that does sound better. 3. Oh my god. This is the best part of this game. Everybody can go home. We didn't need to. This is all we needed. Alright, let's hear the strings one more time then. It's at a reasonable speed. It's gonna take a while to build up. Alright. Cool. Alright. What were these other things? Like these shiny things? Copyright 2025. Yeah. It's weird that it's in the future. I also think it's weird that Parts Plus is free shipping. There's a star on it. LCDs. NAF coprocessor. 20/4. Oh, that's cool. Oh, this is actually pretty cool. Expansion, so you can do more cool math stuff. Prototyping only. I wonder why that's the case. You probably just don't have like some agreement signed with them. So that's what I would guess. This weird security thing. Oh, it's a security thing, which is why they black box it. It's like, oh, we secure it. That's like not that good. Yo, security algorithms should be open because otherwise, freaking people don't know what you're doing, and you know, if there's a mistake in it, you won't catch it, but the black hats will. Spiritual connection. What? In addition to accelerometers and gyroscopes, cool. The miniaturization of divination using MEMS. MEMS is what micro-electromechanical systems, and is actually a big field of research nowadays, both for Mechie and for EE. You can do things like making tiny cantilevers. A cantilever is a beam that kind of stretches outwards, and then so you can press down on it. They make an array of all of these tiny little cantilevers so they can measure force and pressure. Miniaturization of divination. I don't really know why divination had to be miniaturized, but okay. Ancient learning was modern manufacturing. Okay, so also the thing is that, like, the nice thing about Shenzhen IO is they keep all of your data sheets in one place, right? Because otherwise, you know, like, I have to freaking, like, go on DigiKey, one of the main electronic sourcers, and just, like, comb through data sheets, right? But I feel like for this, they, like, distill all of these interesting data sheets and say, like, these are all of the parts you can use, and only these parts. It's so much easier than, like, I have to go on DigiKey and, like, look at everything and just be like, which one fits for me? Oh, let me see. Oh, I guess I can't solder that, blah, blah. There's something nice about having a limited paint palette of just, like, you know, like, you can only paint in blues, you know. Having the amount of, like, detail within there, but also, like, it's encouraging creativity, right? I feel like if I was just given, like, here are infinite FM mixer things, like, that would be really daunting, but this is sort of more contained. That's nice. Okay, what are we doing with MEMS? Oh, this is actually, well, if you were to believe in I Ching, then this is, like, actually not bad. So basically, like, oh, let's use MEMS so that, like, when you toss coins or stuff like that instead, we'll just use this. So they basically, like, make miniaturized Yarrow stocks, it looks like. I've had friends who do the tossing coin version of telling fortunes with I Ching. Painstakingly recreates the narrative. This is actually kind of cool. I was really skeptical about this, but now reading about it, like, this is actually kind of cute. Alright, users mechanical into electrical. Generates a hexagram. This is bull, but whatever. Precision milled. Feng shui. Alright, this is kind of funny. I like this. Oh god. Do I have a PGA 33X6? No, and I also don't have the I Ching one. So. Alright, what is this bull? See, so here's your inverter. You've got like your buffer, and then you also have an inverted thing. And it looks like they all get nanded into something, but it's only one arrow and an or. I think it's a flip-flop. I think this is a flip-flop. A flip-flop is like your base unit of memory in a computer system. So basically, like, there's a latch that says yes or no to, like, rewrite the memory, and then you can access it. It looks kind of like that, and I think, well, we'll find out. Like, what Chinese... This means one! This means one. Yeah, there's my Chinese skills. Recognize words quickly and easily. Natural language control. Oh, that's cool. Supplemental data. Oh, okay, here's our... I need to find the... What was the part that I have? I have an LX100R. What? LX? Why do I have parts that I don't have data sheets for? If I just slap a little thing on there. What is this for? Like, I guess I have a switch? I can click the switch back and forth. I can, if I turn this screwdriver, I can cause this value to increment. I can click this button, and that's about it. Huh. I wonder, to add a custom screen to the sandbox. Look for the Parts Plus catalog page in your manual for more information. Okay. So, I don't have any, virtual fidget cube. I mean, isn't that kind of easy? Because I just like slap a whole bunch of these things on. One second. Let me clean up a little bit so I can save this little. Man, I'm glad I found the sandbox. I was like, how can we not have a freaking sandbox? It's a freaking Zachtronics game. But all right, so I'll get rid of all this stuff. Can I like? No. Oh, rip. Well, I guess you're gonna live in the corner then. Can I save this? I will save this as radio. Alright, let's make a fidget cube. I don't really... So I guess fidget cube is already sort of an interesting thing, because that's definitely part of like this post that I still haven't written, Chinese meme-factoring, of like someone made a Kickstarter of this idea of a fidget cube, but like manufacturing mass production takes a really large amount of time to do. And so someone looked at it, commissioned some Chinese factories to build it cheaper and faster than the other people could do. And yeah, they went to market first, and people don't really care about who's first, as long as you know, somebody, as long as they have the product. I don't know what this thing is. N4BZ1000. Just gonna do a quick search, not worth pulling up the thing. Yeah, N4BZ is not in my data packet, so whatever. Yeah, I wonder how these things work. But like, yeah, look, here's your fidget cube. Are you happy? Is this what you wanted? Button. Still don't know what this thing does. I'll turn this frickin' value thing. Although I don't really know how, fidget cube accurate it is for you know, to require a screwdriver to do things, but you know, I don't know you. I don't judge your life. Is this just an LED? I think this might just be an LED. Okay, let's just friggin' move 100 to B0. Just turn everything on. Ah. Oh, it is an LED. Right. Oh, so can I like let me copy that code from radio. So let's see. So yeah, just copy all of this. Can I save copies from between files? That would be dope. Yeah! Okay, cool. What was I doing? Oh, I don't need this. Okay. Move accumulator to P0. Alright. Oh. I only need to sleep 1. Oh, so it is sort of, yeah, it is light dependent. Okay, cool, we have LEDs. Oh, that's sweet. Alright, sleep 1. Okay, I don't need, I'll just move from 0 to ACC, and let's simulate it through. Yeah, that is certainly brightening and stuff. I can make the world's slowest LED strip, because I've got freaking, I've been working with the Adafruit NeoPixel LED strip. Yeah, so I got red, I got green, I got blue. And those are really fancy. They're really overkill for what I need, but it's been sort of fun to play, having like my own light show and stuff like that. Oh, it's just nifty. Man, I like that there's a sandbox, and also that it's not freaking in the manual what everything is doing. So you really just get to play around with it, and you have to figure out. Minor complaint about these LEDs is that they're not direction dependent, because normally you would have to, whatchamacallit? Yeah, literally light emitting diodes, right? They can only go one direction. So, I don't know what all this for nonsense is, to be honest. So I'm curious how these buttons work. Is it like, oh man, I'm so happy. I'm so happy about this. It's also a lot better than the freaking, what was it called? How's the MC4000X different from the, oh, this one's just a pure Xbox one. Okay. I'm just happy that, like, the sandbox here seems like more reasonable than like the TIS 1000 one. Maybe this is just because I'm an embedded systems engineer. Like I work with electronics and stuff like that. But for the TIS 100, like the assembly language structure was more of a pain than it was a like delight to work with. Whereas this, I'm just like freaking out and like being like, ooh, look at all of these components I can move here. Alright, so let's see how this works. But yeah, like it's more fun. Alright. Oh, okay, so it's 100 when you're pressing it. Okay. What is this thing? What if I hook this up? I have a feeling I do this. It might be a buzzer. It's a mosquito buzzer! Oh, it's so annoying! It's so annoying, it's a mosquito buzzer! I'm sorry, I'm really sorry. This is probably really dumb to listen to. I'll go put this on radio. Oh, yes, just listen to that. Just listen to that singular 82 tone. It's exactly what you wanted in this world. Oh my god. I'm very happy right now. It's also just a synchronized, annoying pitch sound as the lights are going up. Click, 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 click. Oh my god, this is like the Fidget cube from hell at this point. Oh, man. Oh, I'm having fun. Man, see, I'm enjoying streaming. It feels really weird I'm not gonna lie, just to be like talking most of the time and like corresponding to text. Oh, this is an X bus. That's interesting. And then corresponding via text, like I've been punting on sending out my radio form show, but like this honestly feels like a radio show without all of the like radio aspects. I'm just kind of talking to myself. And funnily enough, the skill that's like most prepared me for this is the coding interviews. To be honest, because I'm gonna break this so that I can still play around with things. Because for coding interviews, the number one thing that you have to do is you really have to talk about your thought process while you're working. And so that's what I really feel like I'm doing, especially for more of the coding sessions, is just really just like talking about what I'm working on while I'm doing it. So I wasn't expecting that. Okay, yeah, so this is working as expecting. Like I just turn it and it updates the value on there. Okay. So I wonder if this switch... So one thing that's starting to annoy me right now is that I can't rotate components. Like even components like this that have a rotate thing, like it's just a flipping thing, it's not actually a rotation thing. What's up, TJ Hands? Yeah, but like I really could use with like a rotation thing here. Pin type mismatch. What? How does this work? But I totally forgot what I was talking about. Yeah, hey guys. Yeah, I'm just playing around in the sandbox right now. I can go back to the missions later, but oh man, wait till you hear this like really annoying buzzer. I want to see. 1 second, I'm gonna figure out what this switch does. And I love this buzzer. It's so annoying. So okay, that's interesting. So we've got a toggle switch here. We've got our normal hold down button. We have this weird like potentiometer, I almost want to say. Like you turn it and it sets it to a certain value. Not really sure what these big data banks are. I'm gonna do a quick Control F into the manual. 100p. Yep, it's just a RAM. 14 random access memory cells. 2 independent auto-incrementing memory pointers. That's cool. Yeah. So there's RAM and ROM differences between whether you can write to it or not. That's interesting. It'll probably... Oh, it's a 200p. Like, it'll probably be useful when the problems start getting... Oh, it's just more, I think. It'll probably be interesting once the problems really become harder. What happens when you put 2 different values on 2 different LED pins? Oh, like, it changes the brightness of it. So, I mean, like, yeah, it just changes the brightness, the value that you push out to it. I also don't know how you were expected to know that these were in LED pins. Like, I guess, like, in the picture, like, you can see it's showing a color, but these really don't look like LEDs at all. But yeah, so it would just be, like, one's bright and one's not. Okay, I think I'm done with the sandbox. So, I mean, like, a Jeopardy buzzer, right, it would literally be, like, it sort of bothers me that there's not a toggle switch. Oh, I see what you mean. Okay, I'll try that. Okay. I'm gonna disconnect this. Disconnect this. God. Freaking buzzer. Let's get one of these things. Alright, so I'm gonna move. Alright. What are you just slapping microcontrollers everywhere? So I'm gonna move P0, say like 100, and like let's see P0 here. Okay. Pin is not connected. Yeah, well. Oh, P1. Let me just run my programs as bad code. God, make this more realistic. Not realistic enough. 30 out of 30. There you go. Huh. Huh. I don't know. This didn't really do... Let's disconnect this. Okay, Okay, maybe let's not, like, maybe let's put this at, like, 50. So it's, like, half brightness. Huh. I wonder if it takes, like, the highest amount. Yeah, I think it takes the highest amount. That's really weird behavior. I wonder if I have another one of these and I want to get P1 into ACC, do I get the value? No, I don't get a value. Huh. Huh. I don't have data sheets for the, oh, rip. I'm not sure if it was working or not. My stream seemed to have cut out on my second computer, so I don't know if I'm still talking or not. Yeah, I should be still streaming. Weird. Whatever. That was weird. I don't know why my computer cut out, but it seems like I'm not really sure why there's 4 different data points. And I also don't have a, what's the word? Data sheet for these LEDs. So, not really sure what to make of it, but I can't seem to get a value from the LEDs, which makes a lot of sense, but we're just gonna keep going with the flow. So, yeah, I'll keep this unplugged and see what we get. Huh? Why is this not... Oh, it's because the other ones don't have... Oh, maybe that's it. I didn't have a sweep command in here. So that it was sort of just stuck. So yeah, so this one is trying to increase the power. And we got 2550. Interesting. I don't really know what's happening, but I also don't know why there would be 4 points to it. Like, I'm not really sure what would you want to get from it, but whatever. Alright, so that's our fidget cube. I'll make sure to connect this really annoying buzzer, and I'll probably just get rid of this RAM memory. But yeah, it's a good time. Radio. Alrighty. Custom LCDs, we can make retro-style handheld games. Design and create an electronic game. I don't want to get rid of the subjective, though, because, like, I want to, like, if I do, does this mean I get, like, a icon for... There's no way for us to verify this, so we're trusting you. Yeah. I wonder if I get this means keep loading, we promise you we made a game? Fine work there. What should I make a game about? Electrical engineering? Ha! Yeah, that would be a terrible game. Okay, at least it kept a, gear here so that I could go back to it. I was really hoping for, like, a sandbox icon on this front page, but you do what you can. Rip. But at least, like, the thing that I was worried about would be, like, oh, I wouldn't be able to see the sandboxing area. But I did make a game. I made a freaking, fidget cube and a radio, so. Okay, it's probably not a good game. Like, what am I supposed to do? Like, make Tetris? Like, I don't even have... I guess I have, like, 4 buttons that I could do. But maybe later. I'm still at tutorial mode right now. Alright, little help. What is this? Console... Okay. For gaming stuff. Let's open up the design. Simple inputs connected... Oh! Okay. That we were frickin' going to do for Tetris. X and Y are connected to a joystick, A and B are connected to buttons. Radio receiver, radio transmitter. When we receive a packet over the radio from the game console, respond with the 3-value data packet. Oh boy. What is X and Y? Oh, so this X and this Y. And then some logic based on what A and B are. Oh boy. Okay. Do they have a picture of it? They don't have a picture of it. Alright, hunting this for now. Let's see if the military-industrial complex game is easier. Alright, let's see. Time is the clock, which I was complaining was not a crystal. Oh, that's cool. Oh, huh. I'm not allowed to change these. Interesting. Time is an input connected to a clock. Sensor is an input connected to a sensor. Alarm is an alarm. Cool. When the time equals the on time, it should be off. Well, what kind of values does this get out? Okay, thank you. Alright. Oh, that's cool. Flip it to be this direction. Huh. Anyways, when the time is... Alright, so what kind of values do I get out of move P0 to ACC? The on and off times are set by the operators using dials that can be read as X plus inputs and use numerical values. Okay, yeah, that's what we tried out in the sandbox. Yes, sorry. Oh, it literally counts. Wow, okay. Okay. So this literally counts, and then what? When it's 93, it should be armed. When it's armed and it reads a value of 20, then alarm output should be active. Alright, that's not too bad. Alright. I want to use a fancier one so I can store it in the data, or I could. They're all X buses, so yeah. All right. I wonder if no. Oh, it's not actually better. All right. So connect these here. Connect here. So I want to have this output to say this one. So P0, and I can have X1. So both these X1 hit. Okay. Because I need to have one of these out here. I don't really want to use yet another one of these. So, oh, this is where this comes into play, where it has the more X buses. Okay. Let's turn off these, with this, with this. Yes. Alright. Here. I think I want to do this one out here. Okay. What am I doing? Okay. So I am saying that I should, so when this one is armed, so I basically can ignore I basically can ignore it until this one is ready to go. So if it's armed, then jump to armed. And then I'll go to check otherwise. So let's make this start. Start, sleep one, jump to start. it's gonna block regardless. So I don't think I actually need this. I'm gonna say move x1 to ACC. Because otherwise it's going to block the entire time. So if x1 has any value, oh, because if it's 0, yeah, it could be 0. So I'm gonna say, okay, I had to do the original thing I was meant to. If it's greater than 0, can I just Control Z all this? Yeah, okay. Jump to arm, otherwise sleep 1. Okay, and sleep 1 and then jump to start. Okay, so now that I'm at arm, I want to check if it's greater than, I want to check if P0 is greater than 20. And then if it is, move 100 to P1. If it's not, move 0 to P1. Okay. Sleep 1, jump start. Okay. Cool. Alright, so I'm going to move P0 to ACC, and then I want to check if it's equal to on time. So what is this? X3. When it's armed, if P0 is equal, okay, if P0 is equal to, okay, so when it's to, what is this, X3? Alright. So, it's always going to be on, so I don't have to worry about this, like, buffering. So, and if it is equal to P3, I'm going to say move 1 to dat, and have that as, like, a marker. And then I'm going to say if P0, check if P0 is equal to X2, and if it is, move 0 to dat. X2, I said. Alright, so there's our logic for if it's going or not. Okay, otherwise it's going to default to that state. So now I'm going to check if dat is greater than, if dat is equal to 1, move what, 100 to x0, and if it's not, oh, I don't even need to use that. Whatever. Bad programming. Well, I mean, I have to use this for, oh, if it's not, sorry. Move 0 to x0. Okay, let's try this out. Sleeping. Alright. Okay, so, okay. Let's see. Going. Doesn't matter what sensor is. Okay. So now I see this is, it is equal. So now dat of 1, t equals dat equals 1. So I'll move 100 to x0. So it's equal to 0, so I jump to arm. I check if P0 is greater than 20. It is, I move 100 to P1. I sleep for 1. I jump to start. Okay. Yeah, okay, so I move, and it's, but P0 is not greater than 20. Oh, I forgot the friggin' plus on this one. Okay. Oh, still not right. Okay. Okay, still not right, okay. Alright, so that is still 1, we still move 100 out. Okay, so jump to arm. Check if P0 is greater than 20. It's not, oh, okay. So if it's not, we move 0 to 1. Right, so the trick is we'll move 1 up here. I think that works. No. Okay, so if it is, we jump to start. Move 0 to P1. No, I don't think we need this. I think we need sleep 1 here. And I think sleep 1 here. I mean, I could save some instructions by saying jump to sleep and then calling this sleep. Alright. Cool. Looks like we did it. Whew. Alright. Oh, god dang it, what? Error at the last minute. Freaking. It's probably some freaking, like... Why is there no step backwards? I guess because it's like a freaking embedded system. Alright, so it's 42 and... It might have just been the efficiency trick that I had done, but I know where to stop it now, so. Simulating. Alright. Advance, okay. Alright. So 84 moves in. Alright, so that's our off time. So we move 0 to dat. So that's not equal, so we're moving 0 to x0. Okay, cool. So I'm sleeping 1. Oh. Okay. I still need a move 0 P1 here. Yeah. Okay. Just like the last use case. Oh, I have breakpoints? Well, I don't want to go through all of the things, right? Because, like, there's... Oh, frick. Is it breakpoint? Oh, control click to the... Oh, nice. Thank you. Thank you, 21 centimeters. Control click. What is a profiler? Oh. Okay. That's useful, too. Control click? Can I just scroll forward? Oh, whatever. Let's try this. Ah, freaking crap. It's probably just another one. Please pause. Oh, I think I already added my breakpoints. No. Okay, I think here's the problem. Alright. 57. Alright. 58. Okay, so that was it. Okay. So keep the third breakpoint. These two, okay. Thanks, yeah. Okay. 58. Oh, it isn't equal to 20. Okay. Whatever. Boop, boop. Yep. Figures. Continue. Yeah, screw you. Alright, 17 lines of code, but wow. Probably some more efficiency could have been done here. That's probably what it was. Anyways, see you in the email. well received by our partners and is set to be integrated by various defense and security firms. Thank you for contributing. Or becoming a defense supplier? Yeah, dude, Carl, you should have. I was talking about this the entire time. You know, we're doing military-industrial complex stuff, but whatever, Carl. Increase simulation speed. Oh, I see. Okay, let me just open this. Oh, okay, so this one down here. Ooh, super fast. Okay, cool. Thanks. Thank you. 21 centimeters. Okay. Let's check the mail. Feel the connection and get ahead from BuddyBots.friends. Lack of real-life ties can lead to depression. Aw. Ah, yes, you only care because of the performance at work. Don't let the lack of human interaction reduce your effectiveness. Virtual friends are nearly indistinguishable. Ah, yes. There was something going around recently about, like, somebody accidentally posted some JavaScript code into, like, some Skype spam bot that they were dealing with, and it just, like, started revealing all of their different chat options. So, I do feel like your virtual friend is probably like that. Personality designers. A flirtatious sidekick. See, flirtatious sidekick. Here we go. Subscriptions are flexible and comparatively priced. Feel the connection. Become a top contributor to your company's success. Tag, you're it. Laser tag. Laser tag's fun. With an app, build laser tag arenas. The awesome Plex. Some scorekeeping wearables, and I said yes. I'm not entirely sure why. It'll look brilliant. Of course, the PM really likes it. A lot of simple inputs, either on or off. Too many for a microcontroller on its own, but a good use for the DX300. What is the DX300? Ah, yes. Is this literally? Yeah, this is literally a multiplexing input, I think. Alright, this looks complicated. Okay, so yeah, I think that's pretty much it for this stream. I will try one more time to do well in Solitaire, but yeah, I'm pretty happy, and it sounds like the sound quality was a lot better this time than last time, so I'm happy that I figured that out. The issue actually turned out to be stereo versus mono. Apparently, like, the stereo effect was just picking up a lot more than desired. So, okay, let's see if I can win this game. And then we'll call it a day. But, doopadoo. Aight. So here's the jong. Okay. So, okay. If I patch... No, this is a 5. So, okay. Fa. So, if I put that bybond then up, then... Unless I have to get this fa out without showing this one? Seems kind of dumb. Because I feel like you should just be able to... When all 4 dragons have a single star. Dude, this is a really bad combo. Well, I'm just gonna try it and see if this works. Nope, okay. So, that's really bad. Whatever. New game. Alright, let's see. 3 to 2. 4, 3, 2 to 4, 3, 2 to 5. 9, 2, and 8, but then I don't really have anything to do with this 5. So I can't really do that 6 or anything. I can get that 1 out, which would be nice. This 3 to a 2, but then I have 6, and I can move that to there. Yeah, so I think it's worth putting this Vibon out, doing this, and then doing this. Oh, double fa again? Hold up. Grumble. Okay, if I do this 5, 4, 3, 2, I can get that 7 out. I don't really know how that helps at all. And there's a fa here, there's a fa there. Okay. Probably gonna regret this. So So I think it is advantageous to have, but if I put this 9-8 there, I get the 6 out. Okay, I put this 9-8 here, and I get this 5 here. Double dragon of the same color is actually good. I'm up on top counts are exposed. Oh. Okay. Yeah, I'm definitely very new to this game, so I'm trying to figure this out. It does feel... I don't know what the big deal about everyone, like, really digging the Solitaire is. I just feel like... I don't know. I'm here to play... I'm here to manufacture shit. Alright. So, okay. I think this is it. So then I have these fa. So, if I go up here, I get this. And then... What? So, does this work? Oh, so then I can, like, have them all wrap up here. Which, like, that's good. Okay, let's try that. So, 6, 5, 4, 3, 2, 9, 8. Okay, so let's do this. And then get this one out here. Okay. So, let's see. So, oh, the 7, okay. Okay. I might have backed myself into a corner. 6, 3, 2, 4, 3. John. Darn. I think I backed myself into a corner. Rip me. Alright, I was close that game, I feel like. Oh no, I can do this. No, I can't, because the 7 is stuck. Alright, one more game, one more game. Maybe this is why, it's because it's addicting. It's probably more of it. One more game. God. Okay. So... Well, okay, so at least this double dragon seems to suck, because now I can't get that out without this. So I think... this, and then this, this, this. This? If I can get that 1 out. If I can get that 1 out, then I can just get rid of a whole bunch of stuff. So I think I'm gonna force it out. That. That. So let's get all the thaw out, I think. Here's that. So this 3 could go up. But I think the reason they're not correcting is because I might want to put that 2 out there. So let's try that. So put that 3 out there. Yeah. Okay. So here's a 4. I can do that 3 and then... I'll put this 8 here and then put this 3 there and then 7 here. I could get 6, 5, 4. Or I could put this 9 down and then get that 8. And then do everything from there. I think I want to do that. Yeah. Here and then to here, and do that to here, and then I can put this up, and then I can get 2, 3, 4, getting myself a new open space. Okay, I think I'll do that. Oh, wow. Wow, okay. That was a lot better than I thought. Okay. Cool. So... yeah, I can just get... oh, no, because I have... yeah, okay. Let's just do that. And then put this up here and get bye-bye now. Okay. I think I win this game. Finally. God dang it. Okay. Yeah. Get all the Jongs out of here. Hey! Sweet! First win! Alright. I think that's a good place to end off the stream. So, thank you guys for watching. Got my first solitaire win, got my first military-industrial complex application, and had a lot of fun in Sandbox. So yeah, thanks for joining me. I'll be here next Thursday, same time, 9 to 11 p.m. Eastern Standard Time. And thank you guys all for watching. Bye.